Hi.
kindly share your screen? Medyo na off guard ka ba? Caught off guard?
No, sir. Let me just fix this.
Yeah, i-test mo raw muna.
Hi, can everyone see my screen?
Yes?
Okay.
Okay. Sige.
So,
So you may begin, Lianne.
good day to the Thesis faculty, panel, and guests. My name is Lianne Ong, presenting Algae Tech, completing the green loop in an urban ecosystem, an urban algae hub and innovation district for production, research, and development. We begin with defining the fragile city, an emerging social category referring to the vulnerability of cities brought about by the effects of climate change, resource scarcity, and urbanization. Cities are overwhelmed by the aggregation of multiple risks that overwhelms local systems and contributes to the vulnerability of a city. And we draw focus to the aspect of climate change as it affects cities and vice versa. The severe effects of human activity on the Earth's environment have led to increased risks, consequences, and rapid changes on the planet. 76% of greenhouse gases are carbon dioxide emissions, with 75% of this generated by cities. The burning of fossil fuels is the single largest source of global greenhouse gas emissions, with 45% of this produced by the energy sector and followed by the agriculture sector. So this brings us to the problem. How can we reconcile urban development and expansion with efforts to reduce carbon dioxide emissions? In the Philippines, in particular, we are at extreme risk to the adverse effects of climate change. In this context, we examined Batangas City, an emerging gateway and fragile city known as the industrial port city of Calabarzon. It is a first-class component city of the province of Batangas, Philippines, one of the fastest urbanizing cities in the country, and an important urban center of the region. It is a fragile city in the sense that it is vulnerable to risks and disasters brought about by climate change, rapid industrialization, and urbanization. With developments beginning to shift from Manila towards Calabarzon, it is well on its way to becoming the next gateway to the Philippines and another leading agro-industrial hub of the nation. So of course, there's a need to shift towards sustainable development goals and increased energy resiliency. The current situation is that there is rapidly increasing pollution and congestion in the city's urban core, as well as increased pollution and wastewater in the Kalumpang River. Now tell me, what first comes to mind when you hear the word algae? Is it a weed? Is it that green, slimy material that grows in bodies of water? Well, what if I told you that this green organism might be a solution to climate change and a key component in sustainable cities of the future? There's an emerging potential solution in an unexpected source. While the world is looking for alternatives to fossil fuels, algae is an emerging source of energy, food, and a remarkable carbon dioxide absorber. As the demand for renewable energy resources increases worldwide, microalgae offers a viable biomass resource to produce biofuel. So why algae? Well, algae absorbs carbon dioxide as part of their photosynthesis, producing biomass and oxygen as a byproduct. Algae is also developing sustainable and affordable alternative to wastewater treatment systems, all while growing faster than trees and requiring less land area for cultivation compared to other crops. Algae also has a wide variety of applications, being a potential source of renewable nutrition and pharmaceutical products. So algae has gained worldwide interest due to its unique properties, with more and more innovations being designed in order to combat climate change. Countries in America, Europe, India, Asia, and Australia are all beginning to realize the potential of algae and are beginning to shift developments towards it. The Big House in Germany was one of the pioneering structures of the technology, with the Cloud Collective Farm in Switzerland as another example that utilizes the highway's carbon dioxide emissions in order to transform the area. So we need to anticipate algae's green future in the core of urban cities, where the city is most vulnerable due to risks brought about by climate change and urbanization. For the conceptual framework, we see how the general issues of climate change, urbanization, and food insecurity lead to the three elements of sustainability. The project vision is in line with the Sustainable Development Goals of the United Nations, further being expounded into three overarching goals and objectives, which is designed for the sustainable environment, design that is responsive and dynamic, and designed for social welfare and the community. The three-pronged design approach to the project showcases the relationship to the city, people and society, and the environment. This, in combination with algae technology, brings us to the design concept of an urban ecosystem, making the connection and simultaneously examining interactions across multiple sectors. So with the urban ecosystem being the cities that people live in, it is an interchange and a collaboration of systems that work together. And to represent this, we have this symbol that showcases the idea of an urban ecosystem. So now we go to the design. So key concepts that were used in this project were the ideas of eco-urbanity and eco-urbanism, with the former assuming that sustainable cities can only be truly achieved if both natural and urban systems are considered together. So with this, we propose Algae Tech, algae's green future in urban cities. The key issue is anticipating the integration of algae in the core of our major cities and how this can be a contributor to sustainable development and the next zero carbon economy. Algae Tech refers to the integration of an algae biorefinery with architecture in order to address the current issues of climate change and shift towards renewable energy. The Urban Algae and Innovation District is a combination of an algae biorefinery alongside research and education techniques in order to reduce carbon dioxide emissions, develop algae research and technology, and empower agriculture in cities, as well as foster public environmental awareness and propagate algae as a technology. For the site analysis, the following criteria was considered. First, being a node and a landmark as an area with intense activity and potential. The proximity to the river and the city's primary growth center was also considered as nearby areas with congestion and pollution, as well as the site's accessibility and connectivity and future development efforts for waterfront rehabilitation and linear parks. So the entire site was approximately 7.10 hectares, but this was further scaled down to around 5 hectares. For the microsite analysis, the landmarks were considered, as well as the transportation and congestion of the site. The sun and wind path, vegetation, as well as the sources of noise and pollution from places with high activity were also considered. So for the site schemes, you can see here the vehicular access and the main roads, as well as the planned linear waterfront park and riverfront views. Pedestrian traffic was then considered leading to the site and to the waterfront, with the spaces finally being zoned onto the site. The user profiles were divided into three, with the production and processing division, the program and professional workforce, and the general target and visiting users. For the design vision, we see how the elements of regenerative sustainability, productivity, and development come together to more directly involve communities at the core of its activities and work towards environmental resilience and regeneration. So possible stakeholders and investors that are interested in further developing the microalgae industry here in the Philippines would include major microalgae companies such as Euglena in Japan and Celana in Hawaii. And in the Philippines, there is actually an emerging microalgae industry and several potential stakeholders that are interested in further developing this. In fact, in 2011, there was a proposal for the establishment of the Philippine Institute for Algae Research and Development in line with the goals of the government to shift towards renewable energy. In 2013, there were plans for a Philippine microalgae industry, a 5-year algae research and commercialization master plan that would further research and develop Philippine strains of microalgae. So studies have already begun with UP Los Baños in partnership with UP Visayas and Bohol's Island State University as well. And here is a conceptual roadmap for the project detailing further possible expansions such as wastewater treatment in the future. So this brings us to the design concept of the idea of a greenhouse. The project is akin to an urban greenhouse, housing algae cultivation units as an extension of urban agriculture. Green is not only a predominant color in the project, but it also serves as an antithesis to greenhouse gases, as the microalgae enclosures sequester carbon dioxide and produce oxygen and biomass as a result. For the massing studies, the building mass was first extruded with the courtyard in the center to make room for these two trees that were already pre-existing in the site, as well as to emphasize the waterfront views. The building heights were then adjusted and divided into two buildings for education and production respectively, with emphasis on the south-facing facades, resulting in the following form. So with this, we have Algae Tech, an urban algae hub and innovation district for production, research, and development. So with this, we have the resulting site development plan with the Algae Research and Innovation Hub as an innovative urban space that explores the value of addressing sustainable and technological issues. Our design for Algae Tech seeks to strengthen and develop the existing communities while expanding the area's diversity through new spaces to work and share knowledge. The elements of the master plan are tied together through multifunctional buildings, installations, and spaces that open out towards the streets and create an engaging urban environment. So this includes the Innovation Hub, Auditorium, Algae Tech Park, Production Center, and algae farms. For the project, we see how the three elements of production, education, and research come together and form Algae Tech, an urban algae hub and innovation district for production, research, and development. So this is the exploded isometric diagram of the site and the buildings, including the Innovation Hub, Auditorium, research offices, labs, and production center and algae farm. And the space programming once again brings to mind the idea of an interchange of systems. So we first begin with detailing the Innovation Hub, stemming from the belief that innovation is not in the mind of a single discipline, but it happens when different people actually come together and different fields of knowledge are merged. So the ground floor houses the guest parking and entrances, and the second floor is dedicated to exhibit spaces, as well as a cafe and an annex that leads to the auditorium. The third floor is dedicated to workshop areas and the Learning Resource Center, with additional conference rooms and a multi-purpose hall. The exhibit area of the Innovation Hub was designed with ramps that ascend the building structure in order to promote a more interesting user experience as you go through the various exhibits. The fourth floor houses classrooms and student labs, mainly for training and application. This aims to raise awareness of information and algae as a developing industry. And the fifth floor provides access to the roof deck of the Innovation Hub, where solar panels are also located. So for the facade of the building, green-colored sun shading devices are used in order to draw public interest and resemble algae for the design concept of a greenhouse. And here are the section views that detail the spaces of the Innovation Hub. For perspectives, this is the ground floor of the exhibit area, showcasing the ramps that lead to the higher floors alongside a tree of life structure that symbolizes the connection between elements in an urban ecosystem. So here are views of the exhibit areas on the third floor, as well as the classrooms and the student labs. The auditorium serves as an annex of the Innovation Hub, with seats enough for 178 people. While this is primarily intended for educational use, such as lectures and talks, this may also be rented for private and public use for additional income to support the facility. We go now to the production and research arm of the project, the Production Center. So the laboratory and production facility houses research spaces and laboratories. So taking a whole value chain approach, the project combines emerging microalgae concepts with technological and process innovation with aims to further research and development. The ground floor houses the main biorefinery dedicated to processing the algae, as well as the algae greenhouses. The other half of the building is dedicated to the administration spaces, with the second floor housing the administration offices as well. The second floor of the building is dedicated to supporting the main biorefinery with laboratories dedicated for additional processing, such as for pharmaceutical products. Here you have the perspectives of the biorefinery and the administration office. And the third floor is reserved for research on algae bioengineering, the development of algae bioenergy and bioproducts, with the fourth floor reserved for chemical research and biology. The fifth and sixth floors are dedicated to research offices and the dorms, with the seventh floor leading to the roof deck. Here we have a perspective of the south facade of the production center with the algae tubular photobioreactors and service area. So here you have the elevations, with the sections also showing the zoning of the production center. For the design translation, we wanted to integrate microalgae cultivation in the facade of the building through tubular photobioreactors that are adopted from previous studies. And this is just a general chart that details microalgae strains that will eventually be studied in the facility as it progresses through the roadmap, with an emphasis at the beginning on Chlorella vulgaris due to its versatility and adaptability, as well as its availability here in the Philippines. So this is a schematic diagram detailing the processes of microalgae cultivation within the facility, where it is cultivated, harvested, processed, and results in a variety of byproducts. This type of project is the most feasible economics-wise for algae, as it integrates different processes in order to generate new valuable products, maximizing overall efficiency. The facility hopes to offset the economic cost of cultivation through combining biomass generation with other high-value byproducts such as pharmaceuticals and nutraceuticals. The algae greenhouse houses the open raceway ponds for microalgae cultivation, taken from a scaled-up laboratory-scale raceway that houses approximately 3,000 liters of microalgae culture. The greenhouse serves to protect the ponds from the elements, while the plastic material still allows enough light to penetrate. And we have here a diagram that just details the processes and systems within the facility, where we can see how sunlight is utilized for electricity through renewable energy systems and plant cultivation, leading into the algae systems. We go back to the idea of the Algae Tech Park, promoting innovative production and design. Areas for research, study, and collaboration bridge the gap between knowledge and production and support the teaching of new skills and methods. It is a hub connecting the city, the environment, and the people. So here you have a perspective of the central courtyard park with the pavilion in the center. And the tech park may also house their algae innovations and installations to draw public attention, such as the biolamp and the algae pavilion. So for materials, this would be a hybrid structure primarily made out of reinforced concrete, structural steel framing, ETFE film panels for the roofing frame of the innovation hub, treated wood and timber, and aluminum. For structurals, the building foundation is made out of single pile foundations given its height and location, and the building framing is made out of composite steel framing. This makes it more versatile and economical compared to other types of construction, and the building core is also made out of concrete shear walls. And this is just a conceptual isometric that details the water line of the facilities, with most of the bathrooms located in a typical layout. And with that, I'd like to leave everyone with a quote, that we need to turn algae into more than just the weeds of our future, and together, imagine Earth not just as the blue planet, but one that is green. Thank you.
Thank you, Lianne. So for this session, we'll have Sir Gozon as the chair, and Sir Butch and Sir Yo will be the members. So you may have the floor, Sir Gozon.
Sir, mukhang gusto nang mauna ni Sir po. Naka-on mo siya. Sir, kayo na. Sir, ang tapos
it's actually very good. It's just that doon lang sa last slide mo, it's very clean. Very clean presentation. Oh. Anyway, yun lang yung last slide mo. Biglang you just made a in the utilities part. But up to the last few slides, right? The pace was good, the progression was good, the sequencing was good, right?
Thank you,
Okay,
sir.
but of course, so it's more than enough. Okay, I just have a couple of questions. So, what are the maintenance requirements of your algae? Ano ba yan? Do they? Ano ba? How may maintenance component ba yan? May mga chemicals ka right?
It's not really chemicals, but it's more of like housing the algae culture, and that's gonna be like pumped throughout the tubes.
Okay, so the tube, yung tube ba yun? Forever na yung ganyan? You won't change it?
We
It's
have to
gonna be a
replace it, sir,
permanent.
every now and then. I remember one of
again, you'll be changing it every now and then.
Yes, sir.
You'll be servicing it. So are they detachable? What is your method in making it possible that they can be installed, reinstalled, serviced? How are the tubes?
Sir, it was modeled after this company that supplies algae tubing. I have
So may standard sizes ba yan? Do they have
Yes,
based
sir.
on their handouts?
This is
So
the company.
ano dyan? What are the special mechanisms which
Oh, this
affect your? Can you disconnect those yan yung mga blue ones na yan?
Yes, sir. Those are the connection joints, and then
Okay.
this is the U bend.
Okay.
Since it's tubular photobioreactors, it's like more convenient to maintain compared to the flat panels that I proposed last semester.
These are all tubes, right? No?
Yes, sir.
Even the one on the side are also bioreactor, algae bioreactor. Even this is bioreactor also, right?
Yes, sir.
Okay, so it's an entire bioreactor. The whole thing is a bio. So can you take out components part by part? Ganun ba
Yes,
yan?
sir. Alongside because of the connection, it like becomes modular where you can like remove the tubes and
I see. So
then
this is standard
clean
length
everything.
and like that. What exactly do you harness from this? Electricity?
The biomass, sir. So the biomass is
Biomass.
yeah. And then
So
it's
kailangan mo
further
palang
processed.
so where's your biomass reactors?
It's in the first floor of the production center, the biorefinery, sir.
I see. And so in your complex, how much mass are you going to be do you expect to produce? Or it's not easy to do that at this point?
For the production facility, we're estimating around 300 units. So that's around
300 units
of the tubes, sir.
So okay, so in one tube, how much biomass can you extract?
I calculated it for like the total already. So
Okay,
it's around
so this is, for example, assuming everything is working.
Mm-hmm.
Everything is working, and then what is your how much biomass are you able to extract?
So that's around 7,875 kilograms per month of biomass per 300 units.
And in the after your bioreactor, how much watts of electricity?
No, sir, it's the biomass. And
then what is once it's processed, what happens to it? Fertilizer?
You can further extract different byproducts from the biomass. So if you want to focus on like energy production,
yes, so
that's around 50,000 kilowatt hour per month.
Sige. So you have over 700,000 kilograms, right? Am I correct?
Yes, sir, per month.
So per month. So where will you put all of that?
Oh, there's storage.
Hindi naman sabay-sabay yan, right?
No naman, sir.
Is your storage ample for?
Yes, sir. And in the processing for the biomass, it's basically dewatered first. So the water is like extracted, and then the biomass becomes these like dried chips,
becomes
which makes it like easier to store.
Okay. Anyway, so you can include all of those, okay? And the
Okay.
tubes, of course, are more resilient than panels, I think, I would imagine. No?
Yes, sir.
But there's also panels available.
Yes, but I think the tubes are more viable here in the Philippines because
And then
at
you
least
can
there
also
would be
bring this.
circulation.
Do this have to have direct sunlight always?
Around 10 to 16 hours, sir.
I
With
see. So
the
in your kahit na direct sunlight, direct.
mm, well, yes, or
Okay,
like
so
that's
in your development, are all of these bioreactors facing the sun path?
yes, sir. It's on the south facade of the
Okay.
production facility, and
Okay.
it's slightly angled,
Sige.
around 15 degrees.
Okay. In your laboratories, did you consult any of the algae and the seaweed laboratories in UP?
Um,
More.
I based the laboratories
The marine
on
scientists. Did
not
you ask
specifically the
any of them?
labs, sir.
Huh?
Not specifically the labs.
Okay.
I based it on an existing project for like other algae.
Yeah, but
Labs.
those projects might be westernized, right? It lacks a
Mm.
little bit more. Wala ka bang clean rooms? Do you need clean rooms? Do you
Oh
have
yes, sir.
clean rooms?
There's the anteroom for sanitation and the prep room before you go into the actual lab itself. But then the only clean labs that you need are the organic chemistry lab on the fourth floor. While the other labs they don't really need like sterilization.
And there is no danger of biohazards.
No naman, sir.
Completely none, even in the pharmaceutical section.
Mm.
You
But
sure?
if ever I will have a separate disposal for chemicals. And
Your disposal system, okay? Yun lang. That's okay. Maybe what I will request is a nighttime rendition of your perspective.
Okay.
Okay? Not bad at all. Not bad. Very
Thank you, sir.
systematic. Very well rehearsed. Okay. Go. Finish na.
Sir Chua?
Yeah, hi, Lianne.
Hi.
Is this a government or a private institution?
I was thinking that it could be a combination of like the government, the academe, and like other institutions.
Even foreign countries.
Yes, sir. Because there was actually plans for the Philippine Microalgae Institution, but it didn't push through because of the pandemic. So I was thinking that maybe this could sort of, bring that back.
It's not. This is going to be a public-private partnership, something like that.
Yes, sir.
Is this tied to any academic institution or educational institution? Because of course it needs supply researchers, right? So where would we get the researchers?
I was able to, I think for right now, in terms of microalgae research, UP Los Baños is really good at, so maybe you could partner with that. I was able to talk to two of the researchers who were in charge of the phycology and microalgae lab there. So that could be a collaboration.
Yeah, well, I guess it's good, of course, that you have a tie-up with the academic institution. My concern na kasi it's in Los Baños. Although you're in Batangas, that's what, like a 2-hour drive? Let's say around 1-hour drive, depending on the traffic situation. Kasi minsan it's nahihirapan din kasi kumuha ng academic mga researchers if they live far away. And if they're going to also teach kasi in Los Baños, it's going to be quite difficult to commute from one place to the other.
Sir, if ever, maybe also Batangas State University. I think they also have a microalgae program.
Yeah, I think that will be a better answer. I think you should tie up with them. Because kasi yung nakikita ko nga sometimes institutions like these, they also provide dormitories for researchers.
Oh yes, sir. There's dormitories on the
yeah, so that's good because they could spend part of the time here tapos while commuting to whatever institution that they're going to teach.
I think it's shown in the section. Okay, sir. On the fifth and sixth floors, there's researcher dorms
Okay.
alongside the office spaces.
So may residential component ka pala dapat. Okay. What type of waste does it produce yung facility?
I was thinking like wastewater.
Anong klaseng waste ang pinoproduce niya?
Generally algae is non-toxic, so just maybe I could look into that more about the waste.
Yeah, do you need to treat the water? Especially pag process ng biomass, do you still need to treat the water?
I don't think so, sir, because in my research, I actually discovered that microalgae is used to treat wastewater. So I don't think that you will need to further treat the waste of the microalgae.
Is this salt or fresh water?
The main strain that I want to focus on is fresh water, sir.
Fresh water, okay. Kasi natakot ako pag salt water yan, tapos natapon mo lang sa tubig, sa river. So tinanggal mo na yung diba? Tinanggal mo na yung, kasi I don't remember you had you had that, you had the pond. You were trying to treat also the river water, right?
Mm-hmm.
If I remember correctly. Tinanggal mo na yun?
Yes, sir. Because but when I tried emailing Batangas, they said that they don't have a sewer line, or they don't have a map of the sewer line. So I thought that it would be difficult to include that in the project. So I included it as maybe a future expansion of the facility instead.
Okay. Did you consider energy production as part of your kasi right now you're just producing biomass, right? But did you consider as an alternative energy production for the entire facility using that biomass?
Yes, sir. Also the energy production from that biomass after it's further processed.
But are you producing enough energy to supply the entire complex right now?
I think it has to be used in combination with solar energy. And then I think it's still a few years before it can completely be zero energy.
So you're not aiming for net zero, or
it's a process that's working towards net zero.
Okay, sige. I also noticed that you actually expanded your facilities nga. Kasi dati you were only concentrated on a small portion of the site, right? Ngayon medyo you expanded all the structures already, which is good. Your facility is actually very, how can I say it? It's very, I think gusto ni Doc Butch. It's very laboratory-like.
That's correct.
Yeah, it's very like College of Science.
Yeah, baka naman you should present it to the College of Science.
Yeah, well, yeah, I understand.
Or the MSI.
Yeah, I was thinking kasi I guess should all facilities look like that? I was actually looking for something a bit more, what do you call it? A bit more, just slightly elevated a bit, right? I'm not sure if it's due to time or because I didn't see a progression of.
When you design someday, Lianne, always put your buildings on a podium. Okay? Always, any building.
Yeah.
It goes to all of you. Okay? It goes for all of you.
So I was looking how did you generate the form? And it's more utilitarian, diba? Your approach is more, these are the spaces, these are the programming. It's that. So it does look like a very utilitarian building for me. We just added embellishments ng sa labas. I was actually quite distracted in the tree of life structure in the middle that you placed in the lobby because it felt like the National Museum so much, right? So I'm not sure if it's a paying homage or it's like a rip off. I'm not sure yet. I would have advised you to have chosen a different structure sana kasi nga masyado siyang malapit. But
because
anyway.
I chose that structure because I thought it would complement the algae well, if ever maybe expansion of the facility would include algae tubes going up the structure, so people could sort of
yeah, understandably. Actually, I'm not sure if it's psychological, but I'm actually quite put off by the green color.
Oh no,
So-
sorry, sir.
Edinista yan eh.
Yeah. So yun lang. Then it's my personal preference. Maybe it'll grow on me later on. Because it's kind of, diba? It's green water it's not something that is psychologically acceptable. I'm guessing, right? As opposed to let's say green vegetation. Of course, it's not.
Yeah. Actually, you can experiment with color.
Can you put a tint on algae?
I think it's better to not tint the
Or
maybe
glass
through light.
because
Too light?
through light.
The tubes can
Magiging
be
discotheque ka na paggabi. Pupunta ka na ng mga karaoke niyan.
Light show.
I think also, Lianne, your development lacks a child, an area where a group of kids could play for a more
understandable,
like,
yeah, because
like a-
I think tama nga kasi if you're one of the main users kasi is adolescents, diba, for field trips and school trips, then I think yun nga, it feels kulang ng play.
Mm-mm.
Play yung ano.
especially especially if you're gonna be training the younger ones, right?
Yes.
Okay.
Aside from that,
Tapos na pala part.
that's it. Yeah, it's just one minor comment. Sa manuscript, can you increase the size of the floor plans scale?
Sorry.
I was trying to look at it. So sobrang laki pa nung file, nagka-crash yung PDF.
Oh no, sorry, sir.
So, yun lang. Just increase the scale. Siguro mga kahit 150 to 100 ka. And laki kasi ng white space tapos ang liit lang ng drawing.
Sir, is it okay if for the smaller floor plans, it's a different scale compared to the
Yeah.
other floor plans?
Yeah, as long as you have a key plan, that's fine.
Okay.
Yes.
Okay na yun. That's it. Thank you.
Thank you.
Wala bang natural predators ng algae? Like insects?
No, sir. And if ever it would be protected like
Fish?
inside the
Flies,
greenhouse.
maybe flies, no? Kasi may biomass ka na eh. Maybe
Wala,
just
one last
flies.
question. How do you prevent yung smell? Kasi ba you're storing biomass? May amoy ba yun?
No, sir. There's no smell for
No
algae
smell?
biomass. Yeah.
Okay, sige. Thank you.
Anyway, Pat.
Okay, thank you, sir. Thank you, Sir Chua, Sir Boat. Hi, Lianne.
Hi, sir.
I'd like to congratulate you because it's a clear presentation. No? But ayun nga, and I'm actually happy that I'm last kasi mas konti na lang yung questions na tatanungin. But I do still have some. No? With regards to dun sa production ng algae, paano nga ba siya is it farmed? Tama ba? Is the terminology farmed does it apply to algae?
More on cultivation, sir.
So, people could cultivate
Yeah.
pina-farm din siya.
Yeah, I guess so. I think farm is okay since algae farm.
Kasi pag I think Sir Chua and Sir Boat was bringing it up if chemicals are used, no? And most of the time kasi, like for example, when you look at algae, no, as cited by the previous professors, medyo associated siya dun sa medyo madumi, mabaho, no? Kalimitan, di ba, nakikita natin siya pag kunwari dumadami sewage sa dagat, sa Boracay. Kaya yun yung nagiging rason kung bakit pumapangit yung dagat. Which means that there is actually heavy nutrients, no? Which means that saan mo kukunin yung nutrients mo para mapadami mo yung mass, of course, of your algae.
Sir, the medium for cultivation of the microalgae will have like specific nutrients such as like phosphate and nitrogen.
Hindi ba nitrates kalimitan ang ginagamit nila?
Yes, sir.
So kung nitrates, usually yun yung di ba? Those are excrements. And most of the time kasi, lalo na pag pag farming, napupunta yon sa mga bodies of water, kaya nagkakaroon ng mga pollution sa yung So pag meron kang mga agriculture land into bodies of water like what you have right now, yung river katabi, no? Did you actually consider certain parameters so that you're not going to pollute the river? Or is it baka naman ano, it's too polluted na ba? But of course, you wouldn't want to add more pollution to something. No?
Hmm. I could probably research more on the waste that is produced by the algae, but so far I've always
I
thought
don't
that
think it's the algae that produces the waste. It's the system of
the system.
raising the algae, because you would want it to be ano to, maximize, diba, yung production. So you would add more to have more algae, no? So I think you're going to have some excess of the nitrates. I don't know about the phosphates, but definitely you're going to have excess of the nitrates. And where you're going to ayun, no? Dispose of the nitrates.
Okay, sir.
Okay, is there a particular reason why you chose a site that is beside the river?
I chose Batangas City in particular because in one of the papers by the microalgae institutions, they stated that Calabarzon is like the best place for the microalgae industry due to proximity of like industry in the area. I chose the site in front of the water more so like because of its proximity to the central node of Batangas City where there's more pollution.
But looking at it, kasi titignan ko yung site na mo kanina, it looks like where you located it is a green belt, parang puro puno lang.
Mm.
And now, I think with respect to you looking at, I don't know if you checked about building codes, yung mga ganon, no? But DNR has certain ano to, codes, no? Hindi sila evident here in an urban area like Metro Manila. Like if you check the Pasig, syempre naka-encroach na lahat ng mga buildings halos into the ano. But DNR has existing ones for further developments, lalo na sa countryside, no? I think Batangas could be considered as a countryside pa rin, no? So did you consider proximities, setbacks coming from rivers?
Yes, sir.
What is your setback as of the moment?
There is a 3-meter river easement from the river. I think I did more for that. Just
I think meron yata silang 20-meter na easement
20 meter.
requirement, no? That is why probably right now it's green area kasi hindi siya pwedeng developan, no? If it's going to be a contemporary development. But you could always find reasons, no, to justify why you're developing beyond, no? Kanina na-mention ni Sir, no? Because I think one of the goals of your development is of course ayun, maximization nung production, no? And it was mentioned by Sir Boot, if you followed sun paths. So you were saying that most of your developments are it's facing south?
Yes, sir. The
Diba?
long side.
Maximize yung sun exposure, but I think sun yung parang nakaano siya, but is it really wise to be just facing south, ganun tipo, no? I think you should add a certain discussion on that, maybe highlight the production areas, the production surfaces of your building, and discuss siguro a sun path exposure para ma-discuss mo din kung paano mo na-maximize yung exposure to the sun.
Okay.
And lastly, I think you mentioned it, greenhouse. Yung greenhouse mo na concept, how did that particular kasi you highlighted the concept greenhouse, diba? Paano siya nag-translate particularly dun sa form mo sa space planning ng facility?
Sir, I got the concept from the idea of like an algae greenhouse. So I was thinking like why not the concept for like the entire facility as a greenhouse.
So it only extends to the production of the algae, but not necessarily to the planning of the whole I was expecting sana na ayun, yung structure, tapos may skin, yung ganun, may explanation ka about the skin, may explanation ka about the spaces, arrange like paano bang ang concept ng greenhouse, di ba? You trap certain things within the structure para uminit, ganun tipo. I was expecting na mas ganun yung discussion. Maybe you could do a discussion like that, no? I'm not so sure how it applies into your design, but ako personally, I would appreciate an elaboration that is more para mas ma-discuss mo kung paano nag-apply yung greenhouse concept doon sa architecture mo mismo, not only doon sa production. Okay?
Okay, sir.
Okay, I think that's it from me. No? Okay, thank you very much. The panel, meron pa po tayong mga additional questions?
Yes, ito dito, this plan which is showing right now, right? There's a comment. Your IT room should be in the ground floor.
Okay.
It's like it's like your main distribution panel, your main racks are usually in the ground floor. Okay, for servicing also, right? And then you have also additional racks per floor. And they're not really, pwede namang one whole room, but just these IT rooms have to be present in all floors. Okay?
Oh, okay, sir.
Okay, it's like a banyo. It's like a mech room. Only it's small. And it has to be cool. Okay.
Okay.
Sige. I won't ask any more technicalities.
Okay, thank you, sir. Professor Chua? Anything else?
Okay. I'm okay.
Okay. Sir Balane?
Okay, so we'll just deliberate muna. So I'll put you all in the breakout room. Yan.